Let's study 9th Standard ICSE Chapter 1 of Chemistry, the Language of Chemistry, Sums. Let's start with page number 12 for your practice. Cancel the A sum, let's do the C sum. You have to find the molecular weight. Note that the atomic weights are given, we don't have to learn them. So the relative molecular mass of calcium nitrate, you can also call it molecular weight of calcium nitrate, is Ca plus 2 atoms of nitrogen, that's only 1 atom of calcium, plus this, plus 3 into 2, 6 atoms of oxygen. Now calcium's atomic weight is given as 40, nitrogen's is given as 14, and oxygen's is given as 16. So substitute these values and solve. In the end we have to add them, and the answer is 164 AMU, or atomic mass unit. Next, page 13 for your practice. Question 1. Let's do the B part, percentage composition. Now for percentage composition also, first we will have to find the relative molecular mass or molecular weight. So in the formula we have 3 atoms of calcium plus 2 atoms of phosphorus, because 2 is outside the bracket. So 2 goes for every element inside the bracket. And how many atoms of oxygen are there? 4 into 2, 8. So 8 atoms of oxygen. So substitute the values, atomic weights of the individual elements. Calcium is 40, phosphorus 31, oxygen is 16. These values have been given in the question. Multiply and get the respective answers, and then add them so that we get the total answer, which is 310 AMU. Now we'll find the percentage composition. Since they have not specified any particular element, we will find the percentage of each constituent element. First, the percentage of calcium. Now out of 310, how much is for calcium? It's 120. So 120 upon 310 into 100%. Solve it and you get 38.70%. Don't just copy, work it out in your rough work. Next, percentage of phosphorus. It's 62 totally, 3 into 31 is 62, upon 310 into 100%, that's 20%. Now for oxygen we can do 128 upon 310, or we can just add these two percentages and subtract it from 100, because oxygen will be the remaining percent, which comes up to, always solve up to 2 decimal places. Now let's do the second sum, which is IMP, percentage of water in hydrated copper 2 sulfate. This dot represents a weak chemical bond, and this water molecule, these water molecules which are stuck to copper sulfate molecule are called water of crystallization, which we'll study in detail in the chapter called water. So the method of solving this is the same. First we'll find the relative molecular mass of hydrated copper sulfate. See, without water it's just copper sulfate, but with this water of crystallization it's called hydrated copper sulfate. So substitute the values of copper's atomic weight. So we have sulfur 32, we have 4 atoms of oxygen out here, and we have 5 molecules of water. Now water's molecular weight is already known. It's 1 plus 1 plus 16, hydrogen 1, but there are 2 hydrogen atoms, oxygen 16, so that's totally 18. Then you solve ahead and you get 250 AMU. Now the percentage of water is this 90 upon 250 into 100%, which comes up to 36%. Next we'll solve the page number 15, question 12. Note the cancellations, 2nd, 4th, 5th, 9th, 10th, and we will solve number 3, calcium, aluminium and copper, which has many subparts. So let's start with question 3, calcium. Here the knowledge of valencies is crucial, then it becomes quite easy. So calcium chloride, calcium valency is 2 plus, chloride is 1 minus. So if I do a crisscross method, that is this 2 comes down to chloride, and the 1 goes down to calcium. So I get Ca1 Cl2, but there is no need to write a 1. So answer is CaCl2. With a lot of practice, you'll become an expert in this, and then you can write the answer directly. Now calcium nitrate, Ca2 plus NO3 1 minus. 1 goes down to calcium, 2 goes down to nitrate. But if I shift this 2 down to nitrate 2, first of all, these subscripts are never changed, it remains as it is. If I just write a 2 out here, that's confusing. It looks like 32 atoms of oxygen. Also this 2 is not only for oxygen but for the entire radical out here. So we should put a bracket whenever we have two or more elements in the radical, we have to put a bracket so that the number outside belongs to every element inside it. So this is the final answer. How many atoms of calcium are there? Just one. In this molecule, how many atoms of nitrogen are there? 2. And how many atoms of oxygen are there? 3 into 2, 6. If you don't put brackets, then that's discrimination between nitrogen and oxygen. Next, C part, calcium carbonate. Now, we have to do the crisscross, but always before doing it, we should check if we can reduce the valencies of the cation and the anion, of the basic radical and the acidic radical. So I can cut 2 1s and 2 1s. So now only 1s are left, and if I crisscross it and I don't write 1, so this is the final answer. Next, the D1, calcium bisulfite. So 2 goes down here. Notice how there are more than one element in this radical, so I have to put a bracket out here before writing 2 outside. Here we had just one element in this radical, so we didn't have to use any brackets. Next, calcium sulfite. Again, 2 and 2 gets cancelled, and the final answer is CaSO3. Note that this 3 is only for oxygen, and this will not be changed. Next, calcium sulfate. Well, again, 2 and 2 gets cancelled, and this is the final answer. So it's pretty easy, isn't it? However, you have to learn all the valencies from the valency table. Only then will you get it right. Calcium bicarbonate or hydrogen carbonate. Well, 2 will go for bicarbonate and 1 goes down here. So this is the final answer. Calcium hydroxide, again the crisscross method, and this is the answer. CaOH twice. Next we'll go for aluminium compounds. Aluminium's valency is 3+ and chlorides is 1-. So by the crisscross method it's AlCl3. Similarly, aluminium nitrate will be this. Notice that 3 goes down to nitrate, so this will have brackets. So that totally we have 3 atoms of nitrogen and 9 atoms of oxygen. Next, aluminium carbonate. Again, 2 goes down to aluminium and 3 goes down to carbonate. So this is the crisscross method. Next, aluminium sulfate. Well, 3 goes down here and 2 goes down here, and don't forget the brackets. And aluminium hydroxide is AlOH thrice. Aluminium oxide is Al2O3. No brackets required here. And we don't write the signs, plus and minus signs, in the final answer, of course. Now in the 7th answer, the variable valencies are given in brackets. Copper has variable valency, like some other transition elements, because these elements don't just lose electrons from the last shell, but even the second last shell, that is the penultimate shell. So copper can have valency 1+ or 2+. Fortunately, they have specified which valency to use while doing the crisscross method. A traditional way of writing this would have been cuprous chloride and cupric chloride, because cuprous has a lower valency 1+, and cupric has a higher valency, that is 2+ in this case. But this is the modern method, which is easier. So we have to solve all of these. Cancel tetramine copper to sulfate. So copper 1 chloride. That means we have to consider copper's valency as 1+. So the crisscross is so straightforward, it's just CuCl. But what if copper 2 chloride was given, and the valency of copper to be taken is 2+. So now if we do crisscross, it is CuCl2. Similarly, copper 1 oxide, 2 goes down here and 1 goes down here, so it's Cu2O. But copper 2 oxide, here 2 and 2 gets cancelled and we get CuO as the answer. Similarly, we have copper 1 oxide and copper 1 sulfide and copper 2 sulfide. Here 2 and 2 gets cancelled. Next, copper nitrate. Well, 2 goes down here, so brackets are required here because we have more than one element, and this 2 is for the entire radical. And in copper 2 sulfate, 2 and 2 get cancelled, so we get CuSO4 as the answer. Now let's do question 13. Note the cancellations here, which simply mean that it's to reduce your homework. They are easy sums. If you still wish to do them, do it. So cancel C, J, Q and E, L, S. We'll do all the sums which are ticked. The D1 is IMP. Now if you know the valencies, you will be able to name them. K is potassium and ClO is hypochlorite. So the answer is potassium hypochlorite. So we don't have to show any working here. Just write potassium hypochlorite. And remember, in each of these compounds, one will be a cation and the other will be an anion, except for a few regular acids. Now, D1 is aluminium nitride. In fact, aluminium's valency is 3+ and nitride's is N3-. So 3 and 3 got cut, and that's how the formula was ALN. Next, this is calcium nitride. This one is calcium phosphate. This is actually a regular acid, so we need to remember the names, the common names for it, which is provided in the chapter's table. This is nitric acid. Then this one is sodium hydroxide. This is carbonic acid again. It's a general weak acid, and it's a common name, carbonic acid. This is sodium aluminate. And finally, this is sodium oxide. So here are all the names at one go. Next, let's do the 20th sum, balancing equations. Now in this question, the word equations are given. So first of all, we have to convert it into a chemical equation using formulae. So potassium nitrate gives you potassium nitrite plus oxygen. So if you know the valencies, you will realize that these are the formulae to write. Oxygen will always be diatomic gas. So write O2, not just O. O is an atom of oxygen which cannot exist in nature independently. So remember, there are usually six diatomic gases you will have to deal with in balancing equations. So remember them. Oxygen is O2, then we have hydrogen H2, we have chlorine which is Cl2, we can also have nitrogen which is N2, fluorine is F2, and bromine is Br2. So remember that. But when it comes to metals, well, they are monatomic. So let's balance them. Now you should do it in a long cut method, but I'm doing it mentally because it's quite easy. Potassium 1 atom and 1 atom, nitrogen 1 and 1, oxygen 3 atoms, and here we have 2 plus 2, 4 atoms. Well, the number of atoms of each element in the reactants should be equal to the number of atoms of each element in the products. Then only it will comply with the law of conservation of matter. So just put a 2 out here to increase the number of oxygen atoms. We can't change this number or write anything in between a compound. It has to be written before the compound, which will affect all the elements, but we can't help it. So now oxygen has become 6. Usually we balance oxygen at the end. So let's talk about potassium. Now how do I make potassium 2 on the RHS? Well, put a 2 out here. That's good because our nitrogen is also 2, which is what we wanted. But what about oxygen now? Well, 2 into 2, 4, plus 2 is 6. So this is balanced. Great, that's easy. Next, the third one. Iron plus hydrochloric acid gives iron 2 chloride. It's good that they gave the variable valency to be used because iron can have a valency 3 as well, plus hydrogen. So first write the correct molecular formulae and frame an equation. Notice how the 2 plus and 1 minus got crisscrossed out here. Hydrochloric acid, we should know the formula is HCl. So let's balance it. Note how hydrogen is diatomic, but iron, being a metal, is monoatomic. So we just write Fe. And here we don't have to worry about its valency of 2 plus and 3 plus. That comes into the picture only when we are writing a compound, that is iron with some other element. Then that matters. So here I can see 1 atom of iron, 1 atom of iron. Chlorine, well, we've got more of chlorine on the right hand side. So let's put a 2 out here. So that will equalize the number of chlorine atoms on both the sides. And also of hydrogen, 2 and 2. So that's great. Now it is balanced. Next, let's do lead dioxide or lead 4 oxide. Note the variable valency is given. Gives you lead monoxide plus oxygen. So lead 4 oxide. Well, you can do it mentally or in the rough work. We have Pb4 plus. And oxide is always O2 minus. So first we have to reduce it. So 2 1s are, 2 2s are. Remember, whenever we can cancel stuff, we should. Then 2 goes out here and 1 goes out here. And that's how I got PbO2. If your molecular formula is wrong, then the whole equation will become wrong. Next, lead monoxide. Monoxide means single O. That is possible only if we would have considered lead as 2 plus and 2 minus. So here the valency of lead has changed. That's why we were able to cut 2 and 2 and we got PbO. That was just for your information. Plus oxygen. So let's balance it. Lead 1, but oxygen is 3 and here it's only 2. So we'll have to increase this side. So let's put a 2 out here. So that becomes 4 now. So now here oxygen is less and even lead is less. So let's put a 2 out here. So now lead is 2. That's balanced. And oxygen is also 2 plus 2, 4. That's balanced as well. Next, 7th one. Iron plus chlorine gives iron 3 chloride. Okay, so the valency is 3 out here. So the equation will be Fe plus Cl2 gives you FeCl3. How FeCl3? Well, as I said, iron was 3 plus and chlorine was 1 minus. So 1 was crisscrossed here and 3 went here. That's how I got FeCl3. And chlorine itself, when alone, is diatomic always. Now let's balance this. Number of iron atoms are same, but chlorine is less out here. So let's increase it to 2. That makes it 4. Now I'll have to increase this. So let's write 2 out here. There's no choice. But now iron becomes 2. That's okay. We'll write it 2 out here, so it's balanced. But what about chlorine? It's 2 into 3, 6. Just cut it and write 3. And now it's a balanced equation. Please write A and S answer and rewrite the whole equation neatly again, because initially we have done cancellations, but our final answer shouldn't have any cancellations. Next, let's do the 10th sum. Calcium hydroxide plus ammonium chloride gives you calcium chloride plus water plus ammonia. So first of all, try to write the equation on your own, the compounds. Now check, did you get the equation right? You should know all these formulae by now. You should be the master of valencies. I'm going to do this in the long cut method. So first we make a list of all the elements in the same order. Calcium 1 atom, oxygen 2 atoms, hydrogen 2 plus 4, 6 atoms, don't forget to add. Nitrogen 1 atom, chlorine 1 atom. On the right hand side, calcium 1 atom, oxygen just 1, hydrogen 2 plus 3, 5, nitrogen is 1. Note that this 3 is only for hydrogen, not for nitrogen. And chlorine is 2. So let's start. Calcium atoms are equal. Oxygen is less out here. We'll talk about it later because we've always balanced oxygen in the end. Hydrogen is less, so we'll have to increase it. And here chlorine is less. So let's first equalize chlorine. That will change everything now. Chlorine becomes 2. But that increases nitrogen to 2 as well. And hydrogen becomes 2 into 4, 8 plus 2, 10. That's fine. Now let's try to equalize nitrogen. So let's put a 2 out here. That makes it 2. But now hydrogen becomes 2 into 3, 6 plus 2, 8. Now hydrogen is less and oxygen is less. So how do I increase hydrogen? Let's not increase this number because that will disturb nitrogen. Rather, let's increase this out here. What if I put a 2? Now hydrogen is totally 10. And even oxygen becomes 2. That's your final balanced answer. So write A and S answer and copy this in the end again. So that's how we will do all the sums of balancing equation. Now before we start with the 21st sum, let's do question 24. First one, the B part, which is IMP. Find the relative molecular mass of calcium sulfate. Now, just like we did previously, we first use the atomic weights. So there is 1 atom of calcium, 1 of sulfur, and 4 of oxygen here. And after solving, we get the answer is 136 AMU. Now, what about the second sum, the B part, percentage composition? So before finding the percentage composition, we have to find the relative molecular mass, which is 164 AMU in this case. We have done this same sum before, but in this sum, we will go beyond finding RMM. We have to find the percentage. So out of 164, 40 is from calcium, that's 24.39%. 28, mass of 28 belongs to nitrogen totally, so that comes out to 17.07%. And for oxygen, you can simply subtract 100 minus this addition to get 58.54%. Now let's start with question 21. We'll do all the ticked sums and mark the IMPs. 12th, 21st, 24th, 30th and 35th are IMPs. Let's start with the first sum. Many sums are easy, so I'm going to do it directly, but you all do it in a long way. So sodium atoms 1 and 2 out here. So even before going ahead, I'm going to simply put a 2 out here because I know that will be necessary. Now hydrogen becomes 2 plus 2, 4. This is out 2. So again, I know I'll have to put a 2 out here. So that becomes 4. Carbon is 2 out here, so I have to put a 2 out here. So that carbon is 2 on LHS, RHS, 2 atoms each. Oxygen later, please. Sulfur 1 and 1. Now let's talk about oxygen. Let's hope it's already equal. 2 into 3, 6 plus 4, 10. 4 plus 2, 8. 2 into 2 is 4. So 4 plus 2, 6 plus 4 is 10. So it is balanced. That's the final answer. Next, the third one. Lead nitrate. Pb1, Pb1. But here nitrogen atoms are 2. So we'll have to put a 2 out here. So nitrogen is 2. Oxygen later. Sodium is 1. So we'll have to increase that. So let's put a 2 out here. Chlorine becomes 2. Here also chlorine is 2. Great. What about oxygen now? 3 into 2, 6. And 3 into 2, 6. Great. That's done. Now the fifth sum. Iron 1, iron 1. Chlorine is 3. Chlorine is just 1. So let's put a 3 out here. But that increases sodium as well. That's fine. Put a 3 out here to increase sodium to 3. Now hydrogen becomes 3. It's already 3 out here. And oxygen is 3. It's already 3 out here. So now it's the final answer. Next. Iron 3 chloride. So Fe1, Fe1. Chlorine 3. So let's put a 3 out here. Nitrogen, we have 3 atoms here. So I'll have to put a 3 here. But that would increase hydrogen. That becomes 4 plus 1, 5 hydrogen atoms into 3 becomes 15. Remember that. 4 plus 1, 5 hydrogen atoms into 3, 15. And what about here? 3 into 4 is 12 plus 3 is 15. Great. Number of hydrogen atoms are same. And what about oxygen? 3 atoms and 3 atoms. So now this is the final answer, balanced answer. Next, lead hydroxide. Pb1, only 1 lead. Hydrogen 2 plus 1, 3. Hydrogen only 2. So I guess I have to increase that. But hold on, even sodium is not equal. It's 2 out here. So let's do that first. So this increases hydrogen further. It becomes 2 plus 2, 4. So definitely I'll have to put a 2 out here to make this 4. But what about oxygen? Let's check. 2 plus 2, 4 oxygen atoms. And here 2 plus 2, 4. This is the final answer. It's balanced now. Next, now I'll do this in the longer method. In fact, we should do all the sums with the longer method. Aluminium 1, aluminium 2. So I've just listed down the number of each atom on the LHS and RHS. Let's put a 2 out here. So aluminium becomes 2, but that will affect oxygen as well. That will become 3 into 2, 6. And hydrogen will become 3 into 2, 6. Now this side, we'll have to increase hydrogen, oxygen. What if I put a 3 out here? That becomes 6, and 3 plus 3, 6. Great. This is the final answer. So write ANS answer, write again. 13th one. Zinc 1, zinc 1. Sulfur 1, sulfur 1. But oxygen is 2 and oxygen is 3 out here. So we'll have to increase this. 2, that becomes 4. But it's 3 here, so we'll have to increase this further. So which one should we disturb? Well, either is fine because ultimately both will have to be increased. So let's do this. If I put a 2 out here, now that's 2 plus 2, 4 oxygen atoms. But now zinc is 2. So put a 2 out here. But that disturbs sulfur. So put a 2 out here. So sulfur is 2 and sulfur is 2. What about oxygen now? 2 into 2, 4 plus 2, 6. So cancel, write 3. So that's 6. Now this is the balanced equation. Write ANS answer and rewrite this final statement. Next, aluminium plus chlorine. This seems easy. But Cl is 3, so let's make it 4. That won't help. So we'll have to go further. Put a 2 out here. Chlorine becomes 6. Cancel this and write 3. That's 6. But aluminium has also increased. No worries. Just put a 2 out here. This is the final answer. Now the 17th one. Fe1 and Fe1. Hydrogen is 1, but there is 2. So put a 2 out here. And even chlorine 2 atoms, chlorine 2 atoms. So this is balanced now. Now the 17th one. Lead is 1. Sorry, the 19th one. Lead is 1, lead is 1. Fine. Nitrogen 2, nitrogen only 1. Let's increase it. Let's put a 2 out here. Oxygen later. Hydrogen 1, hydrogen 2. So let's increase it. Put a 2 out here. That increases chlorine as well to 2. That's okay. We've got 2 chlorine atoms already. What about oxygen now? 3 into 2, 6 and 3 into 2, 6. Great. It's balanced. Now in the 21st sum, I've listed the number of atoms of each element. Manganese 1 and 1. Oxygen is less. We'll come to that later. Hydrogen is less out here. So put a 2. So that becomes 2. And chlorine also becomes 2. But still chlorine is less. Note here the number of chlorine atoms totally is 2 plus 2, 4. So actually there's no choice but to increase it further. Let's make it 4. That will increase hydrogen as well. So let's increase hydrogen on the RHS. Let's put a 2 out here. So that becomes 4. That affects oxygen. So that will become 2. And now this is the balanced equation. Write the final answer once again. And now the 24th sum. This seems very interesting, like a marathon sum. Potassium 2, potassium 1. Let's increase it to 2. That changes chlorine. Note how initially chlorine was 1 plus 3 plus 2, 6. And now it will be 2 plus 3, 5 plus 2, 7. Don't forget to add at every step. Now chromium, we've got 2 out here. So let's increase this. Put a 2. That increases chlorine further. 3 into 2, 6 plus 2, 8 plus 2, 10. Oxygen, we'll deal with it later. Hydrogen is 2 out here. So let's increase it here. 2. That makes hydrogen 2. But actually I want 10 chlorine atoms. So I'll have to put a 5 out here. In fact, I'll have to put a 10 out here because it's just Cl, not Cl2. So this jumps to 10. Good, that's balanced. But then hydrogen also becomes 10. Let's increase hydrogen here, put a 5 out here. So the hydrogen becomes 10. What about oxygen now? That becomes 5. That is still less. So we'll have to increase this number further. We'll have to put a 7 out here, simply to make 7 oxygen atoms on the RHS. That changes hydrogen to 14. Now we are forced to write 14 even here to make hydrogen 14. That increases chlorine to 14. But we have only 10 chlorine atoms here. So let's try to increase it out here. What if I put a 3? Let's see what happens. 3 into 2, 6. Plus 3 into 2, 6. 12. Plus 2, 14. Great. Everything is balanced. Check again, once again. Done. Is this a balanced equation? Yes. Write the final answer. That was an IMP sum. Now the 25th sum. So nitrogen is 1 and 1. Hydrogen is 4 plus 2, 6. Hydrogen is 5. We'll have to increase this. But which one should we increase? This one or this one? Let's check other options. Chlorine is 2 and chlorine is 1. Let's increase that first. So that becomes 2. But that changes nitrogen to 2 and that changes hydrogen to 4 into 2, 8 plus 2, 10. Calcium is 1 and 1. Now let's increase nitrogen first. So I'll have to put a 2 out here. And hydrogen changes. 3 into 2, 6 plus 2, 8. So now the only things left to increase are hydrogen and oxygen. So put a 2 out here. That makes hydrogen 10. 2 into 2, 4 plus 6, 10. And that makes oxygen as well too. So that's the final answer. Come on, write it in the end. Next, magnesium nitride. We've got 3 atoms of magnesium. So put a 3 out here. That increases hydrogen a lot. But let's do that later. Let's talk about nitrogen. We've got 2 out here. So put a 2. That's nitrogen. Now, how many hydrogen atoms totally? 3 into 2, 6. 3 into 2, 6. 12. So I guess I should put a 6 here. 3 into, because 6 into 2 is 12. But that would mean 6 atoms of oxygen. Do we have that here? Yes, we do. 2 into 3, 6. So now this is balanced. Next, ammonia plus oxygen. 1 nitrogen, 3 hydrogen atoms and 2 of them. Put a 2. That becomes 4. Put a 2. Hydrogen becomes 6. So when I put a 2 out here, I should have changed this. Make it 4 and this will become 3. And now that I put a 2 out here, nitrogen becomes 2 and hydrogen is 6. Let's increase nitrogen further. Put a 2. So oxygen becomes 2 plus 2, 4. But hydrogen is still less. Cut 3. So 3 into 2, 6 hydrogen atoms. And 3 plus 2, 5 oxygen atoms. Oh no. It's still not balanced. I'll have to increase it further. Let's put a 3 out here, which makes this 6. This is still less. So which one should we increase? This or this? Doesn't matter, because ultimately both will be changed further. So I'm just going to increase this for now, so that oxygen becomes 6. But now nitrogen is 3. Don't forget to change that. So again, this will have to be 3. Nitrogen becomes 3. Oxygen becomes 9. Now we'll have to increase hydrogen. Let's make it 5. So that becomes 10. Oxygen also becomes 5 plus 3, 8. Let's increase it to 4. That makes nitrogen 4 and hydrogen also 12. That means I have to put a 6 out here. 6 into 2, 12. That makes oxygen 6 plus 3, 9. Nitrogen also has to be increased, so I'll put a 4 out here. That makes oxygen 6 plus 4, 10. Still not balanced. What if I put a 5 out here? I guess it's done. Yeah, 4, 5, 4, 6. Correct. So that's the final answer. So rewrite it. That was such an amazing sum. It's an IMP sum after all. By the way, what if instead of 5 we had a 6 out here? Then notice 4, 6, 4, 6, all of them are divisible by 2. That means we have accidentally gone 2 ahead. So in the final answer, what we should do is we should divide the whole equation by 2, 2, 2, cut it, and then write the simplified answer. Only then we will get marks. Now the 31st sum. So nitrogen is 1, nitrogen is 2. So I know that we'll have to put a 2 out here. Hydrogen, oxygen a bit later. Let's talk about sulfur. 1, 1, that's fine. Hydrogen. 4 plus 1, 5. 5 into 2, 10. Plus 2, 12. 4 into 2, 8. Plus 2, 10. So I'll have to increase hydrogen. What about oxygen? Well, 2 plus 4, 6. And here 4 plus 1, 6. 4 plus 1, 5. What if I put a 2 here? Then it becomes 6. What about hydrogen now? Well, 4 plus 8, 12. That's it. Now it's balanced. Because we have hydrogen, 12 atoms on the left hand side also. Check it, calculate it. Don't just copy it. Understand each step. What about this one? Nitrogen 1, nitrogen 1. Chlorine is 3 plus 1, 4. Don't forget to add. Hydrogen is 3 out here, so I'll have to put a 3 here. But now chlorine is 3 plus 3, 6. Just put a 3 out here. That's 6. Balanced. 35th sum. So we'll do it in a long way. Number of atoms have been written. You write it on your own and then cross check here. Pause the video and do it on your own. Come on. Let's see if you are getting it right. So calcium 1, calcium 1. Ready? Hydrogen is less, carbon is less, nitrogen is more. So let's deal with carbon and nitrogen first. Oxygen in the end, of course. Though it is balanced, I guess it will be disturbed. Let's increase nitrogen first. Put a 2 out here. That changes hydrogen. That becomes 4. Oxygen also is changed. 6 plus 6 is 12. And nitrogen becomes 2. Great. But then what about carbon? Well, we have to increase that. So put a 2 out here. Okay. That will change oxygen. 3 into 2, 6. Plus 4, 10. And then that's 11. Hydrogen also has to be increased. Put a 2 out here. That becomes 4. And it becomes 12. And now it's finally balanced. Now the 37th sum. Sulfur 1, sulfur 1. Nitrogen 1, nitrogen 1. Hydrogen 1, hydrogen 2, 4. So put a 4 out here. But the nitrogen is 4. So put a 4 out here. So everything is balanced except oxygen. Let's see if it is. 4 into 3, 12. 4 plus 1, 5. Plus 8, 13. That disturbs everything. We'll have to increase it further. Make it 5. So now hydrogen is 5, nitrogen is 5, and oxygen is 15. You do it in a long way, please. Let me increase nitrogen. Make it 5. So now oxygen is 10, 15. But what about hydrogen? That's 2 plus 2, 4. So that is still not balanced. I'll have to increase it even further. I won't disturb this unnecessarily. Let me increase this first. I'll put a 2 out here. That makes hydrogen 2 into 4 plus 2, 6. So let's put a 6 out here. But now nitrogen is 6. So put a 6 out here. What about oxygen? Well, 6 into 3, 18. And here, 4 plus 2, 6. 6 into 2, 12. 12 plus 6 is 18. Great. This is finally balanced. Now the 38th sum. Copper 1, copper 1. Nitrogen 1, nitrogen 2 plus 1, 3. So definitely a 3 here. Hydrogen 3. Hydrogen is just 2. I'll have to increase it. So hydrogen becomes 4. So I'll have to increase this further. Now nitrogen is 4. What if I put a 2 out here? Now nitrogen is 4. What about oxygen? 4 into 3, 12. 3 into 2, 6. Plus 2, 8. Plus 4, 12. So that's balanced. Now the 39th sum. Carbon 1, carbon 1. Sulfur 1, sulfur 1. Hydrogen 2, hydrogen 2. Oxygen 4. Oxygen 5. So I'll have to put a 2 out here. That makes oxygen 8 directly, but I can't have 5. It'll be multiples of 4. Hydrogen is 4 now, so let's increase it. Sulfur is 2 now, so let's increase it. Let's talk about oxygen now. It's 8 here, right? So 2 plus 2, 4 plus 4, 8. Balanced. Now the 41st sum. Copper 1, copper 1. Sulfur 1, sulfur 1 plus 1, 2. Don't forget to add. So put a 2 out here. Hydrogen is 4, 2 into 2, 4. Hydrogen is 2, so put a 2 out here. Now the only thing left is oxygen. Fingers crossed. 2 into 4, 8. Here, 4 plus 2, 6 plus 2, 8. This is balanced.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.